And welcome back. This is A level math S19709, and today our topic is chapter 3, probability and discrete random variable. So in the previous videos we have done chapter 2. We are done with chapter 2, and we are done with chapter 2, and now we are going to move on to chapter 3, which is probability and discrete random variable. Okay, so probability is the measure of the likeness that an event will occur. Probability is a quantified as a number between 0 and 1, where 0 indicates impossibility and 1 indicates certainty. So we try to take calculate the possibility in a fraction form, right? Between 0 and 1, 0.5, which means equal chances that an event will likely to occur, right? Like for example, if I toss a coin and okay, so this is the fraction. In here you write down the total number of outcomes. So the total number of outcome for our toys coin is 2, because either heads or tail, and I want to know the probability of having a head, so it's 1 upon 2. And if I want to know the probability of having a tail, then 1 upon 2. Okay, so this is how you write down. Now let's do the questions. So this is probability. Okay, a lecturer wished to give a message to a student. The probability that she uses email, letter, or phone or personal contact are 0.4, 0.1, and 0.5 respectively. She uses only one method. Okay, only one method. The probability of the student receiving the message if the lecturer use email, letter, or personal contact are 0.6, 0.9, and 1 respectively. Find the probability that the student receive the message. Okay, so here's what you're going to do. You're going to make a tree diagram, right? So it starts from the lecturer. The lecturer sends either through email, through letter, or through personal contact, and respectively having the probability the probability of sending through email is 0.4, the probability of sending through a letter is 0.1, and the probability of sending through personal contact is 0.5. Okay, and then if for example if she's decide to send a message to email, then what is the probability that the student receive the message? The probability of the student receiving the message if the lecturer use email is 0.6. Okay, either the student receive the message, the probability of receiving the message through email is 0.6, and the probability of not receiving the message through email is 0.4. Okay, that's another thing I want to tell. For example, if I wanted to know that the probability of having a tail is 1 upon 2, right? You toss a coin, and I'm like, for example, if you're playing a game or you're doing gambling, something like that, or you decided that a friend of you has decided to give you a challenge, and he said that if you get a head, then I will give you $50, and if you get a tail, and then you will give me a hamburger, something like that, right? So now you're hoping that you will get a head. So what are the chances of getting a head? Okay, in your favor. So the probability of having a head is 1 upon 2. Okay, the probability of having a head is 1 upon 2. Okay, but what is the probability of not getting a head? The probability of not getting a head is 1 minus 1 upon 2. Then it would be left as 1 upon 2. So the probability of not having a head is 1 upon 2, which means the probability of having a tail is 1 upon 2. So whenever we wanted to know that what is the probability of not having a head or not receiving the email, you're going to minus subtract this 2 by 1, right? So it would be 1 then minus something in order to get the not probability. Okay, so same thing here. The lecturer decided to send it through email, so probability of receiving the message, right? The probability of sending the message to email is 0.4, and the probability that the student will receive that message is 0.6. But what happens if the student did not receive the message? What are the chances of not receiving the message? So the probability of receiving the message is 0.6, and the probability of not receiving the message is 0.5. You just 1 minus 0.6, and then you will get 0.4. Okay, this is how you do it in probability. And so this is how you try to make a tree diagram. Okay, similarly the same thing here and the same thing here, and then it says find the probability that the student received the message. Okay, the probability that the student received the message, you can just multiply. Okay, wait, you can just multiply the 0.4 multiply 0.6 plus 0.1 multiply by 0.8, which is receiving the letter 0.8, and plus 0.5 multiply by 1. Okay, so it is certain, which means the probability for this is personal contact. Okay, so it is certainly, it is completely certain that the student will receive the message because it is written one. Okay, so 0.4 matlab 0.6 plus 0.1 multiply by 0.8 plus 0.5 multiply by 1. Okay, now you need to understand about multiplication and addition. Whenever we try to multiply two probabilities, it means that this and this and this, I mean this and this. Like for example, the lecturer decided to send the message to email. Okay, so she sent a message to email, and then the student received that message. So both are, happening, and they are they are connected. So this and this, or plus means or, this and this, or this and this, or this and this. Okay, this and this you just multiply, or this and this. So she received, the lecturer decided to send the email through send the message through email 0.4, and then the student received the message 0.6. Or she decided to send the message in a form of letter, and the student received the message. Or she decided to send the message in personal contact, and the student received that message. Okay, so 0.4 multiplied 0.6 plus, which means or, 0.1 multiplied by 0.8 plus 0.5 multiplied by 1. So this is the answer. Then it says, given that the student received the message, find the conditional probability that the student receive it via email. Okay, now this is very tricky. It says given that the student received the message. Okay, the student received the message, but the condition is that that person receive it through email. Okay, given that, you will write down in. Okay, so given that the student received the message, which means you're going to whatever you get the answer, you will write down in here, and then find he receive it through email, and then you just take this part, 0.1 multiplied 0. Wait, okay, you're going to take this part, 0.4 multiplied 0.6, and you will write it down in here, and then this is the answer. Okay, so same thing I have done here. Find the probability that student receive the message. You just 0.4 multiplied 0.6 plus 0.1 multiplied 0.8 plus 0.5 multiplied 1. So you got the probability that the student receive the message. Then part 2 is, given that the student receive the message, find the conditional probability that he receive it through email. So given that, but he receive it through email, so you're going to put it in here, and you get the answer. Okay. Moving to the next question. Rachel and Anna play each other at badminton. Each game result in either a win for Rachel or a win for Anna. The probability of Rachel winning the first game is 0.6. If Rachel wins a particular game, the probability of her winning the next game is 0.7. But if she loses, the probability of her winning the next game is 0.4 by using a tree diagram or otherwise. Find the conditional. Okay, first of all, let's see what it's saying. Says that each game result in either a win for Rachel or a win for Anna. The probability of Rachel winning the first game is 0.6. Okay, so Rachel wins the first game, which is 0.6. She loses the game, which is 0.4. If Rachel wins a particular, then the probability of her winning the next game is 0.7. If she wins the next game, then it would be 0.7. If she loses, then 0.3. Okay, and if she loses, the probability of her winning the next game is 0.4. Okay, if she loses, then the probability of her winning the next game is 0.4. Okay, which means right here it would be 0.4, and in here it would be 0.6. Okay, so yeah, find the conditional probability that Rachel wins the first game given that she loses the second. She won the first game. Okay, she won the first game given that she loses the second. Wait, condition, given that, first of all we're going to focus on this word, given that she loses the second. Okay, she loses the second. given that she loses the second. So we're going to take this probability 0.6 matlab 0.3 plus 0.4 matlab 0.6, and then we're going to put this. She won the first game, right? So 0.6 matlab 0.3. Let's see here. Definitely like this. So 0.4 matlab 0.6 plus 0.6 matlab 0.3, given that. But then she wins the first game, so 0.6 matlab 0.3. Given that she loses the game, she loses the game, you just take all the possible outcomes in here, and then you satisfy the conditional probability that she wins the first game. So 0.6 matlab 0.3. Okay, so that's part 1, and part 2 is find the probability that Rachel wins 2 games and loses 1 game out of the first 3 games they play. Okay, so they have extended the game, right? So we're going to just do more of these. Okay, she won the game, and the probability of winning the next game, it says winning the first game, if Rachel win a particular game, the winning the next game is 0.7. So again, this is going to be 0.7 and then 0.3. Okay, she loses the game, and if she loses the game, the probability of her winning the next game is 0.4. So this would be 0.4 and 0.6. She wins the game, 0.7 and 0.3. She loses the game, so 0.4 and 0.6. And then it says find the probability that Rachel wins 2 games and loses 1 game. Okay, Rachel wins 2 games and loses 1 game. So now let's take this. Rachel wins, okay, loses 1 game, right? She won 2 games, so 2 games, she wants 2 games and then loses second, this one. Or she, okay, she won, she lose, she won, she lose, but she won, and this one as well. Okay, she loses, but she won, and she won, this one. And she loses, she won. Okay, that's it. 0.6 matlab 0.7 matlab 0.3 plus 0.6 matlab 0.3 matlab 0.4 plus the 0.4 matlab 0.4 plus 0. No, multiply 0.7. 0.4 matlab 0.4 matlab 0.7. Okay, it's exactly what I've done in here. Win, win, lose, win, lose, win, lose, win, win, and then you got the answer. I hope you guys have understood what is happening in here. Now another question. Boxes of sweet contain toffees and chocolate. Box A contains 6 toffees and 4 chocolates. Box B contains 5 toffees and 3 chocolates, and box C contains 3 toffees and 7 chocolates. One of the boxes is chosen at random and 2 sweets are taken out one after the another and eaten. Find the probability that they are both toffees. Okay. So box A contains 6 toffee and 4 chocolate, which means 10 total. Box B contains 5 toffees and 3 chocolates, 6, 7, 8, 8. Box C contains, okay, 10 again. One of the boxes is chosen at random. The probability, okay. One of the boxes is chosen at random and 2 sweets are taken out one after another and eaten. Find the probability that they are both toffees. Okay, probability of having both toffees. If, for example, the box chosen is A, then the probability that they are both toffee is, you're going to, okay. So the total sweets are 10, right? The probability that they are both toffees, both are toffees. What is the probability? So if I choose box A, and then the probability of having a toffee is, the total sweets are 10, so I'm going to do 10, and then it says 6, so 6 upon 10. Okay, now it says that one of the 2 sweets are taken out one after the another. Okay, now there are 2 things you need to understand with replacement and without replacement. It's taken out with replacement, which means you have taken out and then you just replaced it, right? And the other thing is without replacement, which means you have taken out and eaten it and you didn't replace any, which means there's -1 deduction in a total, right? For example, there are 10 sweets and you have taken one out and eaten it without replacement, so the total sweet would be 9, not 10. Okay, but if it have been if you have been said to that that the sweet have been taken out and with replacement, then the total would not be affected, right? Because you are taking the toffees and you are eating it, but you are replacing it as well. So it's because it's with replacement. So there's no change in the total. So right here it says one after the other and eaten, which means it is without replacement. There's no replacement. So the total 10 would be, it would be changed to 9, right? So I've taken one toffee, I've eaten it. Now I'm going to take another toffee. The probability of having the second toffee is 5 upon 9, because the remaining toffees are 5 now, and the total will be 9. So this is how you do it. And I've choose box A. What if I've choose box B, and and box B contains 5 toffees and 3 chocolates? Okay, 5 toffees and 3 chocolate. Probability of having a one toffee from box B is 5 upon 8. The total are 8. Uh, yeah, 5, 6, 7, 8. Okay. Then having the second one is 4 upon 7. Then what if I choose box C and I want to take 2 toffees, right? So box C is 3 toffees, 7 chocolates, which means 3 upon 10 multiplied by 2 upon 9. Okay, so 6 upon 10 multiplied 5 upon 9 plus 5 upon 8 multiplied 4 upon 7 plus 3 upon 10 multiplied 2 upon 9. And they also have to take in account the probability of having a box. The probability of having a box A is 1 upon 3. Having a box B is 1 upon 3, and probability of having box C is 1 upon 3. Just multiply and then you just add them up and you get this, right? So 0.252, and the probability of having choosing box A is this. So yeah, this is the answer. There are 3 sets of traffic lights on Karin's journey to work. The independent probability is that Karin has to stop at the first, second, and third set of lights are 0.4, 0.8, and 0.3 respectively. Draw a tree diagram to show this transformation. Okay, so you have 3 sets of lights, right? You got red, green, or blue, something like that. Got this traffic light, and so first, say first, wait, first, then second, and then third, right? So in the first one, the probability of being stopped is 0.4, so it's going to be 0.4, and then not stop, you haven't stopped, you just keep on going down, so it's going to be 0.6. If you have been stopped on the first traffic light, then what is the probability of being stopped on the second? Being stopped on the second is 0.8, and then not stopped is 0.2. Let's suppose you haven't stopped in this side of life first. What is the probability of being stopped in the second? So 0.8, being stopped, not stopped 0.2, and then it's keep on going like this for the, so this was the first one, then this was the second one, and this was the third one. So the probability of being stopped on the third set of light is 0.3, not stop is 0.7, 0.3, 0.7, 0.3, 0.7, 0.3, 0.7, and you got this kind of tree diagram. It looks something like this, right? Stop, not stop, and then getting each one. Okay, so you got this tree diagram. Cool. Okay, moving to the next question. This question, bag A contains 4 balls numbered this, bag B contains 5 balls numbered this, bag C contains 7 balls numbered this. One ball is selected at random from each bag. One ball is selected at random from each bag. From bag A you get 1 ball, from bag B you got 1 ball, and from bag C you also get 1 ball. Find the probability that exactly 2 of the selected ball have the same number. So I've done here. So these are the numbers, and the probability of having a 2 is 1 upon 4, 1 upon 4, 1 upon 4, 1 upon 4, since we only have 4. The probability of having 1 is 1 upon 5, 1 upon 5, 1 upon 5, and since they are 2, 8, so it's going to be 2 upon 5. The probability of having a 6, of having 2 is 1 upon 7, 1 upon 7, 4 upon 7, 1 upon 7. Okay, then you have made this. So you have chosen, so the only common numbers are 2 and 8, 2 and 8. So supposing you have chosen 2, probability of having 2 is 1 upon 4 multiplied by probability of having not 2 is 1, since there is no 2, right? So it's going to be 1. The probability of having 2 is 1 upon 7, then plus probability of having 8 is 1 upon 4, not having 8 is 3 upon 5, so this is 2 upon 5, and these are not 8, so 1 upon 5 plus 1 upon 5 plus 1 upon 5, 3 upon 5, multiply by 3 upon 7 of having 8. Then what happens if B got 8 and C doesn't have, got another probability, right? And the same thing here, and then you just add them up, and this is the answer. So we have this question. The question is, box A contains 5 red paper clips, 1 white paper clip, which means 6 in total, and box B contains 7 red paper clip and 2 white paper clip. 1 paper clip is taken at random from box A and transferred to box B. 1 paper clip is then taken at random from box B. Okay, find the probability that of taking both a white paperclip from box A and a red paperclip from box B, right? So the probability of taking a white paperclip from box A is 1 upon 6. And then after choosing that, whatever the any whether white or red paperclip from box A, you just transfer to box B, and then you have to choose red paperclip from box B, right? So the probability would be, in box B it has 7 red paperclip and 2 white paperclip. So if I take the white paperclip from box A and transfer to box B, then the probability of taking a red paperclip would be 7 upon 3, and instead of 2 it would become 3. So total would be, in box B it is 9, but since we are transferring from box A to box B, so it would, the total number of paperclips would be 10. So 7 upon 10. Okay. Then we have here the find the probability that the paperclip taken from box B is red. Okay. Find the probability that the paperclip taken from box B is red, regardless if taking the paperclip from box A is red or white. When taking the paperclip from box B, it must be red. Okay, so I think it would be best if I just make a tree diagram like this. So I've already made a tree diagram. Okay. So in part 1 it says white paperclip from box A and red paperclip from box B. So white paperclip and then red paperclip, so 1 upon 6 multiplied 7 upon 10. Then it says find the probability that the paperclip taken from box B is red. Okay, so from box B is red. So 5 upon 6 multiplied 8 upon 10 plus 1 upon 6 multiplied 7 upon 10. Right answer. Find the probability that the paperclip taken from both A and from box find the probability that the paperclip taken from box A, this is box A, not both A, this is box A. Okay, let me write it down. Okay, from box A is taken from box A was red, given that the paperclip taken from box B is red. Okay, first of all we need to see this, given that paperclip taken from box B is red. Okay, so we already have this answer. This is the given that probability, and now we need to fulfill the condition that the paperclip taken from box A was red. So taken from box A was red. So 5.6 multiplied by 8 upon 10 plus 5.6 multiplied by 2 upon, wait, given that, okay, this is 5.6 multiplied by 8 upon 10. This is the answer. Okay, it's really easy. It's really easy. It's not really that difficult. You just need to make whenever you have been given these kind of question. Number one, you kind of make a tree diagram at all costs. When solving this kind of question, the tree diagram will always help. It always make things much easier. Graphically, it really helps us to understand what is actually going on in this story. Okay, so you just make a tree diagram and just go with it. Another question: Tom and Ben play a game repeatedly. The probability that Tom wins any game is 0.3. Each game is won either Tom or Ben. That wins any game is 0.3. Tom and Ben stop playing when one of them, to be called the champion, won 2 games. Okay. Find the probability that Ben become the champion after playing exactly 2 games. Okay. After playing exactly 2 games, which means the probability that Tom wins the game is 0.3. which means the probability that Ben wins the game is 0.6. So 0.6 matlab 0.6. That must be, oh wait, 0.7. 0.7 matlab 0.7. Then part 2, find the probability that Ben becomes a champion. Okay, Ben becomes a champion. It could be possible that the game has been played 3 times, I guess, because it says repeatedly, right? There's no limit. So for example, if Ben won this game, then wait, Ben won this game, but then Ben loses the game. Ben wins the game, the end, but if he loses and Tom wins the game, right? So Tom wins the game, but then again Ben wins the game, so it happened 2 times, right? But again Tom wins the game. So this is how it will start. Tom wins the game, Ben wins the game, then Tom wins the game, the end, but then Ben lose the game, Tom wins the game, Ben wins the game. So it becomes a this is how you make a tree diagram. Looks something like this. Okay. So Tom wins the game, Tom wins the game. I don't think I should draw this really. Tom wins the game, then Ben wins the game, then Ben wins the game, or Tom wins the game. Okay. Ben wins the game, Ben wins the game, so you don't need to make any further. Ben wins the game, Tom wins the game, then Tom wins the game, and Ben wins the game. This is the probability tree diagram. Okay. Says find the probability that Ben becomes the champion. Ben becomes the champion 0.7 matlab 0.3 matlab 0.7 plus 0.7 matlab 0.7 plus 0.3 matlab 0.7 matlab 0.7. So these are the, you just do this and you got the answer. Part 3 is given that Tom becomes the champion, find the probability that he won the second game. Tom becomes the champion. Given that given that Tom becomes the champion. Tom becomes the champion. So 0.3 matlab 0.3 plus 0.3 matlab 0.7 matlab 0.3 plus 0.7 matlab 0.3 matlab 0.3. Okay. But find the probability that he won the second game. So he won the second game, so you will take this one. Oh wait, yeah, this one. 0.7 matlab 0.3 matlab 0.3. Yes, he won the second game. Okay, so this is the answer. This one. Yes, definitely. This one. Okay. It's really easy. I'm telling you, it's really easy. It's not that. Probability using permutation combination. Okay, you have, or I'm assuming that you guys have understood what is permutation combination. We have done previously in the previous chapter, chapter 1 permutation combination. I've done my video on that, and I assuming that you guys have watched it. If not, it doesn't matter. You have, you don't need to watch it if you already know this. Moving on, probability using permutation combination. A committee of 5 people is to be selected from a group of 5 men and 6 women. What is the probability that the committee contains 2 men and 3 women? Okay, first of all, rule number 1, as we all know, that when making a probability, when calculating the probability, you will always have in a fraction form, which is the total number of outcome and the outcome that we wanted, right? So what is the total number of outcomes? So committee of 5 people is to be selected from a group of 5 men and 6 women. I could write it down like 5 C. Okay, wait. 5 men, 6 women, which means 11 total, 11 people, and you need to choose any 5. So 11C5 is the total number of selection. But what is the probability that the committee contains 2 men and 3 women, which means we are selecting from 5 men we are selecting 2 and then multiply, and then from 6 women we are selecting only 3, so 6C3. So this is the answer. Okay, so this is the total number of selection that are possible, and this is the selection that we wanted. Same thing has been done in here. Total number of possible outcome, choosing any 5 out of 11 people. Or this we can do in this way as well, like we have been doing this in the previous questions, like 2 men and 3 women having the probability 5 upon 11 but left for 4 upon 10, then 6 upon 9, 5 upon 9 for some, and then you just do this. Why we are doing this? Just to get the number of arrangement after selection, because obviously you don't know which one is coming, either a woman is coming or man is coming. You need to make arrangements for that. You need to make arrangement. Okay, why are we not doing arrangement in here? Because it's already been you just assume that doing in this way it's already been arranged and you get the same answer. You can check it out for yourself. You will get the same answer. So either this one applies or this one. But I think uh, even though it looks very similar, but this kind of method uh, rarely being used, because depending on the question, because the question has become so complex that it really becomes very hard uh, to uh, to choose that which method should I use. So most of the time, in my perspective, in my opinion, I choose this one instead of this. Sometimes when there are simple question, I try to do in this way, but most of the time I do in this way just to stay away from confusion. Okay, so if you're trying to use this one, then do not forget that you will do in this way, and you don't need to make an arrange, because it has been already been arranged when doing this way. But in here you just take the probability and then you try to arrange them. You can see here there are 3 women and 2 men, so 5 factorial upon 2 factorial multiplied 3 factorial because of repetition, because there are 2 men and 3 women. Okay, this is how you do arrangement. A 4-digit pin is selected. What is the probability that there are no repeated digits? Okay. Okay, so we have this question. A 4-digit pin is selected. What is the probability that there are no repeated digits? So 4-digit pin is selected. Okay. For first thing here, that what are the total possible number of outcomes for selecting a 4-digit number? So since we are talking about 0 to 9 digits, so total 10, so 10C4, or wait, there are 4 boxes, right? And each box can be selected from any one number from 0 to 9, and assuming that there is no repeated digits, I mean, we are trying to calculate the total number of possible outcomes that can become. So 10C1 multiply by 10C1 multiply by 10C1 multiply by 10C1. Okay, which means 10 of power 4. And now we are trying to select those digits which we need to select 4 digits in such a manner that there should be no repeated digits. So it should be 10C1, then 9C1, then 8C1, and then 7C1. So this is the answer. Same thing as here. Okay. We have another question. A box contains 4 pears and 7 oranges. 3 fruits are taken out at random and eaten. Find the probability that the third fruit eaten is an orange. Okay. We got 3 fruits taken out at random. It could be, okay, the third fruit eaten is an orange. It should be an orange, the third fruit eaten. Okay, so it could be pears, orange. It could be pears, orange, and it could be both. All of them could be orange. Okay, or it could be in this way, that O, P, and O. Now we need to find the probability. For the probability of this is 4 upon 11, then 3 upon 10, and then 7 upon 9. Then doing this way and then add them up. 4 upon 3 upon 10, and you just got the answer. It's very easy. Another, so we have this question. Question is, out of 8 class of 8 boys and 4 girls, a group of 7 people is chosen at random. Find the probability that the group of 7 includes one particular boy. Okay, so since it says that one particular boy, it's a particular boy, it's not any just boy. So we're going to assume that we have already selected that particular boy. It's already in the group. So we're going to say that group of 6 people including this particular boy, right? So there are 12 total peoples, and we have to select only 6. So right, 11. there are total 11, right? So 11 C6 upon 12 C7. 12 C7, which means the total possible number of the total possible number of outcomes, and 11 C6 is something that we wanted, right? So this is the answer. Now for part 2, find the probability that the group of 7 include at least 2 girls. It says at least 2 girls, which means it must be 2 or 3 or 4, right? So you can do in this way, right? So 2, 3 or 4. So having 2 girls, at least 2 girls, which means 4C2 multiplied by 8C5, so total 7. Or we must have at least 3 girls, so 3 4C3 multiplied by 8C4. Or we must have at least 4 girls, so 8C3, which is boys, selecting boys, and then multiply by 4C4. Okay, you just add all of them and you get the answer. Or you can just do it like having no girls and taking all the boys, or having at least 1 girl and then you just subtract by 1 and you get the same answer. Okay, this kind of technique has been used, even though it's part of the probability. This kind of technique has been used in binomial distribution, right? So I think you should check that out. Okay, moving on. Probability on event, disk, dice, spinner, and coin. Question 1. Even throws 3 fair dice. List all the possible scores on the 3 dice which give a total score of 5, and hence show that the probability of even obtaining a total score of 5 is 1 upon 36. Okay. Even throw 3 fair dice. Okay. List all the possible scores on the 3 fair dice which give a total score of 5. Okay. Obtaining a total score of 5 is 1 upon 36. It could be in this way, right? 2, 2, 1, all of them, and you'll get 5. Or we could have like this 3, 1, 1, and yeah, that's it. But we could also get in this way. Instead of 2, 2, 1, we could get like 2, 1, 2 and 1, 2, 2. Similarly, same thing here, we could get something like 1, 3, 1 and 1, 1, 3, right? Like here, like this. So 2, 2, 1, so you get this 1 upon 6. The probability of getting 2 is 1 upon 6. The probability of getting 2 1 upon 6, and for this is 1 upon 6. And then you just multiply, after getting this 2 to 1, obviously it could also be this way, that it could be 1, 2, 1 or 1, 1, 2, which means arrangement is also very important in here. So 3 factorial upon 2 factorial. 2 factorial because there are 2 repeated 2 digits. Same thing here, and then you just add them up and you get the answer. So part 2 is find the probability of even obtaining a total score of 7. Okay, after summing up, right? 3, 4, find the probability of obtaining a total score of 7. Okay, so same thing here, 2, 2, 3, or it could be 4, 2, 1, it could be 5, 1, 1, and yeah, like that. Okay, 115, 214, 313, 322, and just add them up and you get the answer. Another question. Okay, another question is 2 unbiased tetrahedral dice each have 4 face number 1, 2, 3, 4. The 2 dice are thrown together and the sum of the numbers on the 4 faces on which they land is noted. Find the expected number of occasions on which this sum is 7 or more when the dice are thrown 200 times. Okay, so you got 2 unbiased tetrahedral dice, each have 4 numbers. Sum of the number of the face which they land is noted. Okay, so here's what you're going to do. You're going to make like this. You're going to make something like this, and then you're going to add, once you get the 2 dice at the same time, you're going to add up the numbers which they land. So it's going to be 2, then 1 2 is 3 4 5, this is 3, this is 4 5 6 6, this is 4, this is 5, 6 7, this is 5 6 7 and 8. And it says to find the expected number of occasions in which this sum is 7 or more, right? So 7 or more, 1 2 and 3. So 3 upon 16 is the probability. Okay, this is the probability, and it says find the expected number of occasion of which this sum, and it's asking for a mean, and this part is definitely from a binomial distribution. So don't worry about it. If you haven't done it, don't worry. Once you've done it, you will understand this question. Expected number means finding the mean. Okay, and the formula of finding the mean is this: n multiplied by p. Okay, so we already know p, and we already know n. This is 200, so we're going to just use this, and we're going to find the mean. Okay, so this is the answer. Question is: a triangular spinner has one red side, one blue side, and one green side. The red side is weighted so that the spinner is 4 times more likely to land on the right side than on the blue side. The green side is weighted so that the spinner is 3 times more likely to land on the green side than on the blue side. Show that the probability of that the spinner lands on the blue side is 1 upon 8. Okay, so first of all, it says the red side is weighted so that 4 times more likely to land on the right side than on the blue side. Okay, so we have this probability p, right? And it says it's 4 times more likely to land on the right side than on the blue side. So the probability for red is 4p, and as for the blue it's just p, right? And as for the green, it says the spinner is 3 times more likely to land on the green side than on the blue side. 3 times, which means 3p. And then it says show that the probability of that the spinner lands on the blue side is 1 upon 8. We're going to equal this to 1, and we will get 8. So it's 8p is equals to 1, so it's going to be 1 upon 8. So it's going to be 1 upon 8. So this is the answer. So this is part 1. As for part 2, the spinner is spun 3 times. Find the probability that it lands on a different colored side each time. The spinner is spun 3 times. Find the probability that it lands on a different color side. Each time. Okay. So the probability. Okay. So it could be possible that it lands on blue side, then it lands on green side, and land right, blue, red, and green. Okay. The probability of being land on the blue side is 1 upon 8. The probability of being land on the right side is 4 upon 8. Probability of being land on the green side is 3 upon 8, and then you're just going to multiply by 3 factorial, since there will be arrangement. I think this is the answer, and yes, this is the answer. Okay. Okay, let's move on ahead. Next question is, okay, so we have come to independent and exclusive events. What are independent events? When 2 events are said to be independent of each other, one event does not influence the probability of another event. Both events happening at the same time but are independent from one to another. Okay, like for example, you're tossing a coin or spinning a dice. They both are happening at the same time, but the probability of the one does not influence the probability of another event. Okay, so they're independent but happening at the same times. So we use this is A and B. Okay, I hope okay, so this is really similar to what we have been doing so far. In below we write that given that it is this, and find the probability that it is. So it's the same thing, right? It's the same thing here. This part is given that, and then we fulfill the conditional probability, and you got. So it's the same thing as we have been doing so far. You can use the following equation to figure out probability for independent event. This is the formula. Okay, dependent event. One event influences the probability of another event. An event that relies on another event to happen first. Like for example, if you are taking a ball from, for example, in a box, in a box there are so many colors. You got seven red. You got seven red balls and five blue balls. You take you have taken one ball at random without replacement, which means in the which means that you have taken a ball, and because of taking that ball it gave it changed the probability of another event which is going to happen. I mean, for example, if I want to take two balls, right? So I'm going to take first ball, and then and I will not replace it, which means the total number of balls in the box is reduced to one, reduced by one. So it now so this change the probability of another event happening, which means if I take another ball, so the probability would be different because of the first pick. Okay, two events are two events are mutually exclusive if they cannot both occur at the same time. Set of outcome of a single coin toss which can result in either heads or tail but not both. Okay, this is the formula. So we have this question. Roy has 10 cards. 4 of the cards have a 3 pin on them, and 6 of the cards have a 4 pin on them. He takes 3 cards at random, okay, without replacement, and adds up the number on the cards. Okay, show that the probability is the sum of the numbers on the 3 card is 11. This is the probability, and we have to the event is the sum of the numbers on the 3 card is 11, and the probability is 1 upon 2. Okay, so we have 4 of the card have a 3 pin on them, which means we have 3, and it's 4 times. So 3 we got 4 cards which I have printed 3, and then we got 6 cards which I printed 4. Okay, so we have 4 printed 4, but there are 6 cards. Okay, which means and he takes 3 cards at random without replacement, taking 3 cards at random, and which make a sum of 11. So making a sum of 11, in order to do that, so 4 3 4 5 6 7 8 9 10, another 4. This is the only way. So 4 3 4 or 3 4 4 or 4 4 3, it doesn't matter. Probability of having a 4 is 6 upon it's going to be 6 upon 10. It's going to be 6 upon 10 multiply by, it's going to be 4 upon 9, and then it's going to be 5 upon 8, and then just going to do 3 factorial upon 2 factorial since they are repeated, and this is the answer. Now I think if I use a calculator, then it could become 1 upon 2. So 6 upon 10 multiply by 4 upon 9 and multiply by 5 upon 8 multiply by 3, and it's going to be 1, yes, 1 upon 2. It's the correct answer. Okay, then it says event R is the sum of the numbers on the 3 card is 11. Okay, this is event R, we have already know this. And event S is a number on the first card taken is a 3. Okay, I think I need to do this more openly. So 4 3 4 3 4 4 and 4 4 3. Okay, the probability for S, even S is the number on the first card taken is a 3. Okay, but it could also be 3 3 3. It could also be 3 3 4, could be same. Okay, so this is even as. Okay, determine whether event R and S are independent. Justify your answer. We already know what is the probability of event R. This is event R, 1 upon 2. Event S, the probability of event S is 3 cards without replacement. It's up to number of the cards. Okay, the probability of event S is we're going to just add up the probabilities, right? So this is going to be 4 upon 10 multiplied by 6 upon 9 multiplied by 5 upon 8 plus 4 upon 10 multiplied by 3 upon 9 multiplied by 2 upon 8 4 upon plus 4 upon 10 multiplied by 3 upon 9 multiplied by 6 upon 8. So we're going to add them up, and you get the probability for the event S, and then you're going to use a formula. All right, so I think I've already done this, and there you go. 333, 343, 334, 344, and yes, 1 2 3 4 5, and we have here is 4. Something's not right, it could be in here. So okay, fine. So we got 4 of them: 333, 343, 334, 344, and here. Okay, and then you just take it out, and you get the event S, and then you're going to use the formula, which is the independent event formula, if they're independent or not. So the probability of S multiplied by the probability of R, and we need to find this that the common between event R and event S. The common between these two is 344 only, because in event S the first digit is 3, and in event R 3 plus 4 plus 4 is equal to 11. So we're going to take the probability of this. So it's going to be 4 upon 10 multiplied by 6 upon 9 multiplied by 5 upon 8, and you get the probability. There you go. Okay, and now if they are equal, then we can say that they are independent, but since they are not equal, hence not independent. Okay, so this is 1 upon 6 and this is 1 upon 5, not equal, hence not independent. Okay, that's done. Part 3 is determine whether event R and S are exclusive, which means we're going to use exclusive formula, which is PS probability of S plus probability of R is equal to 0. Okay, we're going to okay. So we all know that mutually exclusive means that both events cannot happen at the same time, which means this must be 0, right? Yeah, like we have discussed in here, this must be 0. Then we can say that it's mutually exclusive. Alright, since it is not equal to 0, hence it's not mutually exclusive as well. Deja vu. No. Okay, so this is done. Moving to another question. Data about employment for males and females in a small rural area are shown in the table. Employed, unemployed, employed, male and females. Okay, and then a person from this area is chosen at random. A person, let M be the event that the person is male, and let E be the event that the person is employed. Find PM. We're going to add them up, and we're going to take the total. So the total are 206 plus 412 plus 358 8 upon 5. So we're going to take down the total, and then we're going to take this, and then we get the probability of a male like this, right? Then find this. Okay, so now we need to find the common. So the common is this. We're going to take 412 upon the total. So the total is 1281. So this is the answer. Then are M and E independent? Okay, so we're going to we need to find the probability of E as well. So employed, we're going to take this and have a total. After having the probability, we're going to multiply this M and E, and then it's equal to this. So yes, it's not independent. Okay, yeah, so this is very easy. And part 4, given that the person chosen is unemployed, so we'll take this total, find the probability that the person is female, and then we take this total, and we got this. Given that person is unemployed, this is the number, and person is female, and then you got the answer. Okay, so we have this question. In a group of students, the number of boys and girls studying art, music and drama are given in the following table. each of these 160 students is studying exactly one of these subjects. So we have this chart, and the question is, three students are choosing at random. Three students. Find the probability that exactly one is studying music and exactly two are boys. So let's see the first part, that exactly one is studying music, which means one is studying music, the other two are not studying music, and exactly two are boys, which means uh, two are boys and one is a girl. So it could be in this way, it could be in this way, it could be in this way. And then if you try to see it more closely, then I think you understand this, that this part and and this part is same. This one is different. So we got two possibilities, two types, and you know. So let me remove this. We got these two. Okay. So after getting this kind of this, so after getting these two, so what we're going to do, we're going to take down probability. The probability of being a boy and a musician is 40 upon 160, then multiply by, and not in a music but it's a boy, so 24 plus, so it's 24 plus 32 upon 160, and not in music but it's a girl, so not in music, 15 plus 37 and upon 60, then plus, okay, let me write it down. So being a boy, 40 upon 160, then this is 56 upon, but I'm going to write it down, 55 upon 159, since we're taking one boy, then multiply this, and it's a girl but not in music, so 52 upon 160, which means I'm going to say 52 upon 158. And then since these can be arranged, so we're going to just do 3 factorial upon 2 factorial, since these two are, wait, we're going to do 3 factorial. All three of them are different. This one is a boy but in music, this one is a boy but not in music, this one is a girl but not in music, so all three are different. Okay, then we're going to do plus, and then we're going to do the same thing for this one as well. So the girl is in music, so it's going to be 12 upon 160 multiply by, okay, so it's going to be 56 159, and this one is going to be 55 upon 158. And since these two are equal, similar, and this one is different, so it's going to be 3 factorial upon 2 factorial. I think this is the answer. So we have done the same thing in here. Yes, this is the answer. Okay, moving on. Another question is, in a group of 30 teenagers, 13 of the 18 males which watch cops or kids on television, and 3 of the 12 females which watched cops or kid. Find the probability that the person choosing at random from the group is either a female or watches cops or kid, or both. First of all, reading this, we're going to make a graph according to this the data given. So there are total 30 teenagers. 18 there are total 18 males, and there are total 12 females. So from the 18 males, 13 of them watch, and the remaining 5 doesn't watch. And as for the females, 3 of them will watch it, and the remaining 9 will not watch it. After making this, now we need to find the probability that a person choosing at random from the group is either a female or watches, okay, so it's the first of all, it's saying that it's a female, right? It's a female, which means I'm going to take 12 upon 30, 12 upon 30, then saying or, which means plus, watches cops or kids. Okay, so watches cops or kid, I'm going to take this, so it's going to be 16 upon 30, or both means it's a female and it watches. Okay, so it's a female and it watches, so 3 upon 16, 3 upon 30. and I think this is the answer. Okay, now there's another thing. Okay, so it's a female, it watches, and it's both. Whenever we have this kind of question, like and it's been said like either female or watches this or both, or both. First we're going to do is we're going to make a set diagram. Okay, this is for watch, this is for female. So it's a female and it watches, and this is both. Having the probability that it's a female, we got this. Having the probability that it watches, we got this. And since it's covering, or it's covering this part already, uh, you know like for example, if we try to draw this, it's a female, so it's covering this part, it's covering this part, and it watches, and again it's covering this part. So we're going to subtract by this, not to make two times, in order to be duplicated, since we already, whenever if we are trying to find the probability of being a female, then this one is has already been selected. Okay, so probability of being a female or watches or both, minus 3 upon 30, and you got the answer. Three upon are male, and male student who like their career 3.5, and the proportion of female who like their career 4.5. One student is chosen at random, find the probability that the student chosen is either female. Okay, so it's a female, which means 1 upon 4 multiplied by or like their career hard. Okay, so it's going to be, well, so it says find the probability that the student chosen is either a female. So it's a female. We're going to just 1 upon 4 multiplied 4.5 plus 1 upon 4 multiplied 1 upon 5. We're going to add them up, or likes the curry, hot. Okay, so we're going to add this, or is both a female and likes the curry hot. Both a female likes the curry hot, minus 1 upon 4 multiplied 4.5. So student chosen either a female, it's a female plus likes the curry hot. Okay, likes the curry hot plus and plus, or is both female and likes the curry hot. So minus 1 upon 4 multiplied 4.5. Okay, so this is the answer. This is how you do it. It's the same thing as above, right? And I think the probability chapter is done. This is probability, and now let's move on to discrete random variable. The probability density function PDF of x, or probability mass function, is a function which allocates probabilities. Like for example, if you have been given the probability, okay, same. Random variable means a variable which contains the outcome of a chance experiment. Discrete random variable, a random variable that only takes distinct values. So you have this graph, and the sum of all the probability is equal to 1. You could also be asked about taking out the mean. So this is the ux, this is denoted as mean, or you can call it expected value. Okay, and you can also write it down as ex, which also mean. This is the symbol mean, this is also symbol mean, and this mean sigma of x multiplied by px. Wait, x multiplied by px. Okay, so x multiplied by px. Okay, so in order to find the mean, what you do is use multiply each one, and then plus multiply this one 1 to this, then plus multiply 2 to this, plus the 3 to this, plus, and then you get the mean. Variance is ex, which means variance is, okay, in order to find the variance, what you will do is you're going to square each of these. Okay, so this is the mean. Okay, this is also the mean, but inside you are putting square. So you will take the sum of, you will square each one of them, and then multiply this, then plus this, plus this, plus this, and then minus, you will then subtract it by the mean square. Okay, so that's how you calculate the variance. and that's it. Let's move on to the question. The question is small, medium, large. The prices of bananas are 10 cents for a small bananas, 20 cents for medium banana, and 25 cents for large banana. Calculate the expected total cost of 100 randomly chosen banana. After knowing all of these, we can just make a diagram, right? 10 cent for small banana, okay, and having, so, okay, 10 cent for small banana, and the probability is this. 20 cent for medium banana, and probability is this, and 25 cent for large banana, and probability is this. Calculate the expected total cost of 100 randomly chosen bananas. So what we're going to do, it's since it said expected to the expected, which means we need to find the mean, and in order to find the mean, first of all we're going to okay, calculate the expected total cost of 100 randomly chosen banana. So we will find the mean, and this is our mean, and after finding the mean we're going to multiply this to this. Okay, so how did we find the mean? We're going to just multiply this, then plus multiply this, and plus multiply this, plus, then we get the mean, and then we just multiply this to a set of 100, and you get this. Okay, this kind of question is normally used in binomial distribution and normal distribution, so don't worry, it's very similar. This question is very similar. Okay. Okay, now let's move on. A bag contains 7 orange balls and 3 blue balls. 4 balls are selected and rendered from the bag without replacement. Let X denote the number of blue balls selected. Okay. Construct a table to show the probability distribution of X. So we are focusing on blue balls, but there are only 3 balls, and it says 4 balls are selected and random, and X denote the number of blue balls selected. So we're going to make the probability distribution for the number of blue balls selected. Let's say suppose we have selected 0 balls, 0 blue balls. So the probability of selecting 0 blue at this probability distribution, we need to find the probability of having 0 ball, then probability of selecting 1 ball, probability of having 2 balls, probability of selecting 3 balls. So what happens if we select 0 blue balls? So we are only selecting then we are only selecting 4 orange balls and no blue balls. So the probability of having 1 orange ball is 7 upon 10, then 6 upon 9, then 5 upon 8, then 4 upon 7. Since it's talking about without replacement, the after selecting the ball hasn't been replaced, so we are doing without replacement. And whenever we try to do it without replacement, that means that the total number will be reduced by 1, and the probability for the next ball being chosen also make changes. So this definitely dependent events. Okay, the event of one affect the other event of the probability of one event affect the probability of another event. Okay, so this is the 1 upon 6. This is the probability. What happens if we have chosen one blue ball? Okay, orange, and then finally blue, which is 3 upon 7. And since they can be arranged, so multiply by 4, so 1 upon 2. Then having 2 blue balls, so 2 blue balls and 2 oranges, and they could be an arrangement. We don't know whether we're going to choose orange first or maybe blue first. That's why we are doing arrangement. Okay, so 4 factorial upon 2 factorial 2 multiplied 2 factorial 3 upon 10. So you got this answer. Okay, so this is 3 upon 10 actually. Okay, right, and the probability of having 3 blue balls, so having 3 blue balls means having 3 blue balls, but we need to select 4, right? So we can do something like probability having a blue ball is 3 upon 8, then multiply by 2 upon 7, and then multiply by 1 upon 6, and then multiply by then it's very easy. What I have done here is Okay, one thing we know that after finding all three of this probability, and we should know that if you have if we sum up sum all of this, then it would be equal to 1. So we can easily find this if we do not know what the probability is. Like for example, let's suppose this is x, so we're going to add all of them and then minus 1, right? 1 minus 1.6 minus 1/2 minus 3/10, and you will get 1/30. Okay, that's how you do it. Or you could just do it the other way around, like we have done this, right? The same thing here, we can do this in this way, in that manner as well. Like uh, 3 blue balls selected, right? And then it's orange. So the probability of having a blue ball is 4 upon 3 upon 10. So it's 3 upon 10 multiply by 2 upon 9 multiply by 1 upon 8 multiply by 7 upon 7, and then you just multiply this by 4. And if I just use a calculator, 3 upon 10, 2 upon 9 and 1 upon 7 multiply by 4, so I will get okay, so 3 upon 10 is this is 3 upon 10, then 2 upon 9, then 1 upon 8, then 7 upon 7, and then multiply by 4. Okay, 2 upon 9 and 1 upon 8. Yes, this is the answer. This is 1 upon 30. This is the answer. Same thing as here. Okay, so this is part 1, and part 2 is find the mean and variance of x. Multiply this to this plus multiply this to this. 0 multiply 1 upon 6 plus 1 multiply 1 upon 2 plus 2 multiply 3 upon 10 plus 3 multiply 1 upon 30, and you got the mean. And how to find the variance? So 0 square multiply 1 upon 6 plus 1 square multiply 1 upon 2 plus 2 square multiply 3 upon 10 plus 3 square multiply 1 upon 30 minus mean square. Okay, you have to find the mean, then you just put square on, then you got the variance as well. Second question is, a discrete random variable x has the following probability distribution. This is the probability distribution. Find the value of the constant c. Okay, add all of them, and then since they are equal to 1, we can just do like this. So it's 1 upon 18. Then find the mean. This is mean. Okay, so same thing here. After putting the values of c, we are just going to multiply plus multiply plus multiply plus, and then it says find the probability that x is greater than mean. X means this, so we need to find the probability of this and the probability of this. Since this is the probability, then we're going to just add them. Since they are greater than the mean, must be greater than the mean. So this is the mean 2.8, and 3 and 4 are greater than 2.8, so we're going to add these probabilities, and this would be the answer. Okay, and another question is, a company set up a display consisting of 20 fireworks. The probability that more than one firework fails to work is 0.264. The 20 fireworks cost the company $24 each. 24 fireworks cost the company $24 each. So 24 multiplied 20, so it's going to give us the total cost. 450 people pay the company $10 each. Okay, 450 multiplied by 10 to watch the display. If more than one firework fails to work, they get their money back. Okay, so first of all, they said that the probability of having more than one fireworks being failed is 0.264. Okay, so we can make a probability distribution for this. The probability distribution is first of all, it says the 20 that okay, first of all we need to find the cost. So 20 multiplied 24, it's going to be 20 multiplied by 24, it's going to be 480. This is the cost, and 450 people pay the company $10 each for 50 people. So 450 $10 each, which means 4,500. This is the cost. This is the profit. Oh wait, this is just, it's not yet a profit, so we're going to just make a deduction. Let's see what is the profit. So 4,500 minus 480, and you will get $4,020. So this is the profit, $4,020. We could either have the we could either have a profit. The company could have a profit having $4,020, and the probability of having this is okay. We're going to minus this by 1. 1 minus 0.264, and it's going to be 0.736. Either a company could have a profit, or if more than one fireworks fail, they get their money back. So these people will get their money back, which means the company would put a loss of minus 480, and the probability of having that is 0.264, because it says if more than one firework fail to work, the probability of having more than one firework fail to work is 0.264, and if more than one firework fails to work, they get their money back. So which means they will be at lost. This is exactly what I've drawn, and then it says calculate the expected profit for the company. Expected profit, which means we need to find the mean. So we just find it the mean, and this is the answer. Judy and Steve play a game using 5 cards number 3, 4, 5, 8, 9. Judy chooses a card and random, looks at the number on it and replaces the card. Then Steve chooses a card at random, looks at the number and replaces the card. If their two numbers are equal, the score is 0. Otherwise, the smaller number is subtracted from the larger number to give the score. Okay, so they are playing the card 3, 4, 5, 8, 9. So we are going to make a graph. Equal, so 0, subtracted 2, 3, okay. Okay, 7, 6, 5, so it's the difference is 5, 8, 7, 6. Okay, 1, 0, and 1. Okay, so it's going to be 4, and it's going to be 5. Then 2, 1, 0, it's going to be 3, it's going to be 4, 7, 6, 5, you got 4, you got 6, 7, 8, so 3, and you got 0, and you got 1. Then you got 8, 7, 6, 6, you got 6, then you got 8, 7, 6, 5, you got 5, then you got 4, and then you got 1, and you got 0. Show that the probability that the score is 6 is 0.08. So we got 1 and 2. So it's 2 upon 5 multiplied 5 25. So 25. This must be the probability. And this is the probability. It's the answer for part 1. Now it's saying that draw up a probability distribution table for the score. Okay, so we just make a probability distribution like this. We have made it, and that says if the score is 0, they play again. If this okay, we need to draw the probability distribution, and then we just keep on adding. It's really easy to take it out the probability, like 5 0 to 5 or 25, 1 2 3 4 5 6 6 upon 25. So we're just going to do like this, right? Then it says find the probability that Judy wins the second choice of cards. Judy wins the second choice of card. If the score is 0, they play again. If the score is 4 or more, Judy wins. Otherwise, Seed wins. They continue playing until one of the player wins. Okay. It's saying the second choice. Judy wins the second choice of card, which means in the first choice of card, both of them got the score 0. If the score is 0, they play again. which means first it was 0, and the probability of having a 0 is 1 2 3 4 5, so it's 5 upon 25. And then Judy wins the game, and in order for Judy wins the game, okay, in order for Judy wins the game, if the score is 4 or more, Judy wins the game. 4 or more, so 4 upon 25 plus 4 upon 25 plus 2 upon 25, and this is the answer. Just multiply this. So this is the end of discrete random variable and probability. Thank you so much for watching. I hope I'll see you guys in the next video. So I think it's done. Probability is done, discrete random variable is done, and I've put out some basic questions, though only those kind of questions which could make a complete, which could give a complete picture of what probability a discrete random variable is, and which could build up a concept, right? So yeah, so keep on doing more questions, exam questions, and you will get it right. And I think I'll keep on continue to chapter 4. Thank